Hi everyone, mechanics of material. In this problem, we have two rigid casting A and B over here, and they are connected by a 3/4 of an inch diameter steel bolts CD and GH, CD and GH, and also they are connected with the ends of a 1.5 inches a aluminum rod. This is our aluminum rod, and these are our steel bolts, and this is our rigid casting. So each bolt is single threaded with a pitch of 0.1 inch. After being snugly fitted, the nuts at D and H are both tightened a quarter of a turn, knowing that the modulus of elasticity of steel is 29 megapascal and the aluminum one is 10.6 megapascal. We want to calculate the normal stress in the aluminum rod here in the middle one. So to approach this problem, we have to look at the configuration for free body diagram at each part carefully. The dimensions of each bolt and aluminum rod are provided. And by having the free body diagrams first for bolts and aluminum bar, so these are the bolts one and the center one is the aluminum rod. So as soon as we tighten the bolts, there is a tensile force inside the bolts, as you can see here. And to be compatible at the same side, they are pushing the aluminum rod, as you can see. So if we call that force in bolts like P sub B stands for force in the bolts, and P sub R stand for the force at the rods. The compressive force and tensile force are shown here. So both CD and GH has the length of 18 inches, diameter of 75 inches, 0.75 inches. And if we want to see what is the deformation on each of these two steel bolts, delta B is PL over EA for the bolts, and that's a positive because that's a increase in length. PB is unknown, length is provided, area is provided, modulus of elasticity of steel is 29 megapascal. So we can have a relation of delta increase in length, which is a positive one based off force in the bolt. So if you jot down the delta B is positive 1.4 times to 10 negative 6, 4 times force at the bolts. And do the same for aluminum rod. We have the length, we have all the information. We just write in parametric format for delta of rod based off the force, the compressive force in the rod, aluminum rod. So that's delta R is a negative because the aluminum rod is shrinkage based off the compatibility of the formation in the iron cast, and the displacement of D relative to B. So as soon as we tighten the bolt, there is a relative displacement of D versus B, and that's nothing but a quarter of a pitch is a quarter of 0.1 inches because the pitch was 0.1 inch based off problem statement, and that gives us 0.025 inches in terms of relative deformation of D versus B as soon as you tighten the bolt. And at the same time, we do know delta D with respect to B is nothing but delta B minus delta R. And if we just jump to the rigid casting, you can easily see there is a force of rod which pushes the casting, and two force of bolts because there are two bolts at the top and at the bottom. So free body diagram, summation of forces in x goes 0. It just says PR minus 2 times PB is equal to 0. We get a relation of force in rod which is equal to 2 of force at the bolts. And based off delta d with respect to b, which is from the previous part, and if we just replace, we already know what delta b based off force of bolt, and what the delta sub r based off the force in the rod, aluminum rod. If you just jot down that in this equation, it just gives you numeric value based off PB and PR. There are two unknown here, and if we just plug in the PR, which is 2 of P at bolt here, we just simplified our equation based off only one unknown. And if you just solve the equation for P sub B, force at the bolt, it just gives you PB is 9.3 kilopounds, and P sub R force in the aluminum rod at the center is twice of that, that's 18.61 kips. Stress in aluminum rod, which was the intention of this problem, is simply the force over the area for aluminum rod, and that's 18.61 kilopounds over a quarter of pi times 1.5 inches squared. It just gives us 10.53 ksi for stress at the rod. Thank you. We'll solve more problem.